Now the next topic, that is motion in combined electric and magnetic fields, velocity selector. This is the special case. Now see here, suppose we have the electric field and magnetic field, both are perpendicular to each other, and a charged particle enters in both the fields perpendicular to both field. It implies that now electric field, magnetic field, and the velocity of charged particle, all these three are mutually perpendicular to each other. See the figure. Suppose, as shown in the figure, the velocity of the charged particle is in x direction, electric field that is in y direction, and magnetic field that is in z direction. So we already discussed, in the presence of electric and magnetic field both, the force acts on charged particle, that is the Lorentz force, and that is given by F equal to Q into E plus V cross B. So we can write QE plus Q into V cross B. QE, that is the electric force, and Q into V cross B, that is magnetic force. Now electric force, which is QE. So Q, that is the scalar quantity, E, that is vector quantity. So the direction of the force, that will be in the direction of electric field. And in our case, at present, electric field that is in y direction. It implies that the force due to electric field on this charged particle will be in positive y direction. Now magnetic force, that is Q into V cross B. V, that is in x direction, so Vi caret. B, that is in z direction, so Bk caret. So magnetic force, that is QVB into I cross K. But I cross K, that is minus J. So minus J represents negative y direction. It implies that here the magnetic force, that is in negative y direction. So when electric field, magnetic field, and the velocity of the charged particle, all these three are mutually perpendicular, at that time the electric force and magnetic force acts on the particle are mutually opposite. Now see here, suppose we consider the magnitude of these two forces, that is equal. Suppose magnitude of these two forces, that is equal. So in that particular case, the net force on the charged particle will be 0, and the charged particle will move with constant velocity. So what will be that velocity? So if magnitude wise electric force and magnetic force are same, then we can write QVB, the magnitude of magnetic force, that is equal to QE, the magnitude of electric force. QQ cancelled. So V, that is equal to E upon B. So if electric and magnetic field are mutually perpendicular, and if charged particle enter perpendicular to both with velocity E by B, then in that particular case, the net force on the charged particle, that will come to 0, and the particle will move with constant velocity without changing its path. Clear to all of you?